All right, hello everyone, and welcome, and thank you for coming to the last session of the last day. Yay! All right. So this session is about claims-based authentication, and I just want to set expectations before we start. It's actually an introductory session, so if you are a claims expert, then this may not be the best use of your time. So I'm just going to ask how many people in the audience are new to claims. Perfect. And how many people are claims experts? Perfect. So you guys can stick around and help me answer the hard questions at the end. So, all right, so let's get started. So what we want to cover is a number of things. So as I mentioned, I'm going to start with a brief introduction to claims. We're going to talk about why we're even talking about claims, what are some of the fundamental concepts, what is some of the terminology that is being used, and then we're also going to quickly cover the components and the architecture, and we're going to focus on the Active Directory Federation services in a demo that is going to showcase how we configure ADFS to work with SharePoint in a SAML authentication scenario. And then we're going to talk about some trade-offs and limitations of claims. And we will also cover a little bit of the SharePoint 2013 authentication changes with respect to claims. All right, so what is authentication? So authentication is the process of verifying that someone or something is who they claim to be, and typically requires evidence known as credentials. For example, a client or a client application or a user could present a username and a password, or could present a digital certificate and a PIN, and if these credentials verify, then everything is in order and they get access to the application. Now, in the Microsoft world, authentication is performed by Active Directory, which leverages the good old Kerberos or NTLM. And now, if all the applications in the world would use Active Directory and the whole world would be a single security domain and we'd all trust and love each other, then we would not need to worry about claims. But the reality is different, and we have a number of challenges that we're facing. First of all, organizations use different authentication systems. Not everyone uses Active Directory, and even if they do, they use different instances that reside in different security domains. But they need to interoperate with other organizations' users, or they need to expose applications to internet users. We also have to deal with privacy regulations that are dictating what kind of information we are allowed to capture and store about our users. So this is why we're talking about claims, because with claims, we can interoperate between Windows applications, such as SharePoint, and non-Windows applications and systems, and we can also interoperate between security domains. We can also trust other parties to do the proof of identity check without us having to worry about having to request and manage any personal information from users. So for instance, when you log into a site using your Windows Live ID or your Microsoft account or your Facebook account into a third-party site, you are in fact authenticating to the third-party site without any of your personal information that is stored in your Windows Live ID profile or Facebook profile being shared with that third-party website. Another reason why claims are important is because with claims we can delegate the authentication logic and the user management workloads to another party. So developers and the IT staff don't need to figure out anymore how to find and keep track of identity information for users of each application. Instead, by creating a claims-based application, they can eliminate the need to create custom code, custom authentication logic, and to manage user stores. So basically, instead of the application determining who the user is, it receives a confirmation that the user has been successfully authenticated along with a set of attributes about the users. And these are what we call claims. Another great advantage of claims is that we can enhance our user profile with additional attributes. So say, for instance, we want our application to send an email to the user or to the user's manager or to take a specific action based on the role of the user. Well, this information may be tracked in Active Directory, but if we use Kerberos, for instance, a Kerberos ticket would not include this information. So our application would have to query Active Directory every time and look up this information. So how cool would it be to have all these attributes handed to our application? And this is entirely possible with claims. So a quick note about the diagram. I just want to point out managed versus unmanaged users. So managed users are the users that basically we can block from Facebooking during business hours, or in other words, employees that are subject to all our corporate policies as well as full auditing of their network activities. Unmanaged users, on the other hand, are users that live outside of our corporate world and over which our IT staff has limited power. All right, so what do we need to build a claims-based authentication solution? Well, we need three things. We need an identity provider, we need some standards, and we also need a set of claims. So let's talk about each one of these concepts. So when we talk about selecting an identity provider, we have to consider a few specifics of our scenario. We have to ask ourselves a number of questions, such as, are we federating with another organization whose users are managed by a corporate identity provider, or are we simply exposing an application to the internet to unmanaged users? We also have to ask ourselves if we need and want to manage ourselves the users that are accessing our application, or if we want to delegate the authentication logic to a web identity provider. Do the users targeted by our application already have identities? So all these are important things that we have to ask ourselves before we decide to go down the claims path. The other thing we have to take into account is, of course, the reputation and capabilities of the providers. So as you know, we have a variety of providers to choose from. We have web providers, we have corporate providers, application identities and issued identities are also other forms of identity providers that we can select. The focus of our session and demo will be Active Directory identities in the context of a SharePoint web application. So the second thing that I mentioned in terms of our components for a claims-based solution was standards. So the standard that we're going to talk about most in this presentation is SAML, or Security Assertion Markup Language, which is basically an XML open standard for exchanging authentication and authorization information between security domains. So SAML is a product of the Organization for Advancement of Structured Information Standards, and it's leveraged by the claims authentication stack that is provided by the Windows Identity Foundation. So our focus today is primarily on the claims authentication stack provided by the Windows Identity Foundation, especially as it is extended and applied to SharePoint. But that being said, it's good to know that there are other standards out there, such as OpenID or OAuth, that allow users to be authenticated. For instance, OpenID authentication is currently used by several large websites, such as Google, Yahoo, PayPal. And every time you log in with your Facebook account or your Microsoft account to a website, you are in fact leveraging OAuth. All right, so with this, let's talk about claims a little bit more. So in the real world, the check-in process in an airport is a really good example of where we use claims-based identity. We can't simply walk up to the gate and present our passport or driving license. We have to check in first at the ticket counter, and we present there whatever credential makes sense. Passport for international flights or driving license for domestic flights. The check-in agent performs both the authentication and authorization. So they perform the authentication when they verify that the picture ID on your credential document matches your face, and then they perform the authorization when they look up your flight and they confirm in the system that you in fact have paid for the flight. And if everything is in order, you receive a boarding pass. The boarding pass is in essence a set of claims. So the flight number, the gate number, the seat number all represent claims. And this is actually the equivalent of a security token in the digital world. The special information that we see encoded on the back of the boarding pass proves that the pass was issued by the airline. And the gate agent will trust all boarding passes that have that magnetic strip on the back. Now, in the digital world, this is the equivalent of a security token that is signed by the issuer who created the security token with the issuer's private key. The other analogy I want to make with the check-in process is there may be more than one way to obtain a boarding pass. You can go into the check-in counter in the airport, or you can check in online. So now, the gate agents that are boarding the flight don't really care how you obtain your boarding pass. As long as it has that magnetic strip on the back, then they know that it is trusted by the airline. So similarly, in the digital world, we can produce security tokens through different providers. As long as our application trusts those providers, then we can use them for authentication and authorization. So on the right, we have an XML representation of a digital set of claims. So again, instead of a boarding pass, we're using a token, a set of bytes that contains one or more claims. And each claim contains information about a subject. So the clearest way to think about claims is as a set of information about a subject. So for instance, name, flight number, seat number, as I mentioned in our physical world example, represent claims, or in the digital world, we can talk about email address, organization, or role as claims. Now, the key concept here is that a claim is not just a unique identifier that identifies a resource or an application or a user. It's in fact a set of values that describes a resource or an application or a user. And the other point I want to make here is that we use the word claim instead of the word attributes, which is more commonly used in the enterprise directory world, simply because of the delivery method. So in this model, our application doesn't need to look up the user attributes in a directory. Instead, all these attributes are being handed to the application. So claims are issued by a provider. Claims are issued by a provider, and they're given one or more values, and then they're packaged in security tokens that are issued by an issuer, which is commonly known as a security token service. And you're going to hear that very often referred to as an SDS. So SDS means security token service. It's the web service that packages the claims into tokens. The SAML tokens are XML representations of the claims, as I mentioned, signed by the issuer's private key. And this is how the claims are generated and passed around through SAML tokens. All right. So let's talk about the types of claims authentication modes that SharePoint supports for incoming authentication. And there are three of them. There are Windows. There's Windows authentication, there's forms-based authentication, and there's SAML authentication. And they all generate a SAML token, and they all result in a claims identity object. But the authentication process is different for each. So in the Windows claims mode, SharePoint authenticates the client using standard integrated Windows authentication, which is NTLM or Kerberos, and then translates the resulting Windows identity into a claims identity. In a forms-based authentication claims mode, SharePoint will redirect the client to a login page that hosts the standard ASP.NET login controls. And the page will authenticate the client using the ASP.NET membership and role provider, very similar to the way it used to function in SharePoint Server 2007. And after the identity object that represents the user is created, SharePoint will translate this identity to a claims identity object. And finally, we have the SAML claims mode. And in this mode, SharePoint will accept SAML tokens that come from a trusted external security token service, or SDS. So basically, a user who attempts to log in will be redirected to the external provider, for example, a Windows Live ID or ADFS claims provider, which will authenticate the user and will produce a SAML token. And SharePoint will accept and process this token, will augment the claims, and will create a claims identity object for the user. So now, depending on the authentication path and the claims setup, our SAML token will contain a different set of claims. So for instance, with Windows claims, we'll get information like primary SID or UPN attributes from Active Directory. With forms-based authentication, we'll get, we could get a role attribute or a name identifier. And with the SAML token, we can get custom claims like audience, for instance. What I want to point out here is, if you notice, in each one of this, we have a field called is authenticated. So this is basically what tells SharePoint that the user has entered the correct credentials. So there's no password being passed in here or encoded or transmitted, or there's nothing like that. It's just a Boolean field that tells SharePoint, yes, this user presented the correct credentials or not. All right. So a term that you're going to hear very often is IDP. IDP stands for Identity Provider, and it is responsible for a number of functions. An IDP will authenticate a user, will create a set of claims that is granted to that user, and it will return that claim set to a relying party. So another way that IDPs can be used is to actually redirect authentication requests to other IDPs. And this is very common in a federation scenario. WS-Fed and SAML 1.1 are two other words that you're going to keep hearing, and they're basically protocols that are required to be supported by an IDP in order for SharePoint to be able to integrate with that IDP. And I want to point out something here. So there's a difference between an identity store and an identity provider. For example, Active Directory is not an IDP, but is simply an identity store. And the reason is that Active Directory does not provide SAML 1.1 support or a WS-Fed endpoint. So a WS-Fed endpoint means a metadata endpoint that basically describes the configuration and the certificates of the store. So we can't just simply point, we should be able to just point to a metadata endpoint to obtain all this configuration automatically if we're talking to an IDP that supports these protocols. A relying party, or RP, is an application that consumes the claims to make authorization decisions. And in our context, this is SharePoint. So the relying party application will receive the claims from an IDP, which in our scenario is ADFS. An SDS, or Secure Token Service, is a service that issues claims and packages them in security tokens. And the tokens are then signed, and they can be optionally encrypted. So in particular, the SharePoint SDS is a specialized web service that is designed to respond to requests for security token and to provide identity management. So the core functionality of every SDS is the same, but the nature of the tasks that each SDS performs depends on the role that you assign to your SDS to play in relation to other SDS web services in your design. And we're going to talk more about that in a few slides. Claims provider. A claims provider is usually used for two reasons: to augment claims and to provide name resolution. So claim providers are displayed in the UI of the Select People and Groups dialog box in the People Picker control. And let's talk a little bit more about what the claims provider do. So the claims augmentation is part of a process that occurs after you log on to a claims authentication site. Basically, after a user logs on successfully, all registered claim providers for that web application are triggered. And when the claims provider are triggered, they can add claims that were not provided at the logon time. So for example, let's say a user logged on using Windows Authentication, but you'd like to grant that user an additional claim that looks up in, say, an SAP system and retrieves the purchasing limit for that user because you want to use that in an approval workflow in SharePoint. So this is where claims augmentation comes in. So with a custom claim provider, you're able to do this lookup into your SAP system and assign that to the claim set associated with the user. The other important thing here is that claims augmentation can be performed at any issuer. It can be performed at the ADFS level, or it can be performed at SharePoint level. And in many cases, ADFS will be used because it has the capability to reach into attribute stores such as Active Directory domain services, SQL Server, or even custom stores. But another location that you can use for augmentation is a programmatic extensibility point that comes with the SharePoint STS. So we talked about claims augmentation, and the second function I mentioned for the claims provider was the name resolution. So the name resolution comes in two parts. One is the people picker control, and the other one is the type-in control. So when you want to enable users to search for claims and find claims, then a claims provider will enable you to do this using the people picker. And the type-in control enables you basically to type a username or a claim and then click the resolve button. Your claims provider will examine the input and will determine whether it's valid, and if it's valid, it will display you the correct, you won't get the squiggly red underline under the value. Now, SharePoint comes with some default claims providers, such as, for instance, the SharePoint All User Claim Provider that is displayed with, you see under the people picker with the label of all users. So that's an out-of-the-box claims provider that comes with SharePoint. The one important thing to remember here is that when you configure a web application to use SAML-based authentication, then the built-in SharePoint claims provider will not provide search functionality to the people picker control. So what's going to happen is any text that you enter in the people picker control will resolve, regardless of whether it's a valid user, group, or claim. So if you're planning to use SAML token-based authentication, you must plan to create a custom claims provider so you can implement custom search and name resolution. Otherwise, you won't be able to grant permissions. All right, so how does it all come together? So sign-in is a very complex process in SharePoint, and when we authenticate a user, there are a number of processes that occur. So in the center of the diagram, we have the client, which can be defined as the browser, whether it's Internet Explorer or Firefox or Safari, or we could have the Office client. And the client will make a resource request as an HTTP GET, and this is step one. SharePoint will return to the client and will ask for authentication, in addition to providing an authentication URL that will send the client to the identity provider. So these are steps 2 and 3. Now, the identity provider can be Active Directory, can be Forms, or can be SAML. The client will be asked to produce credentials, and based on those credentials, the identity provider will validate the user, and it will return a token, which again, it could be a Windows NT token, it could be an FBA, or it could be a SAML token. And this token is being sent back to the client, and this is step 4. Once the security token is received, it is provided to SharePoint, where SharePoint creates a new token based on the token coming back from the external trusted provider. And this is step 5. The security token response is sent to the client, step 6, who requests the resource, this time using the security token that SharePoint issued. And this is step 7. So, so just to go over step 6 and 7 a little bit more, SharePoint basically repackages the claim set that it received from the external provider and creates a new SAML token that is issued by SharePoint to be used by SharePoint. So just remember this, that we have one token from the provider and we have another token from SharePoint. So, so again, SharePoint is the relying party in the scenario. And at the end of this process, you will accept the claim and you will convert it to a SP user object. All right, so let's talk about ADFS. So again, ADFS stands for Active Directory Federation Services. And you shouldn't be misled by the federation name included in the name of the technology, because ADFS can act either as an identity provider or as a federation provider. So what exactly does federation mean? So that means that in a federation role, ADFS can actually pass through claims from another IDP, say a partner organization IDP, or it can intercept these claims and it can issue a modified or a transformed set of claims. The same ADFS instance can act in this two roles simultaneously. An ADFS SDS can be used also entirely inside an organization, or it can be exposed on the internet, or it can act in both roles. And the claims that the ADFS supplies can come from Active Directory domain services, but as I mentioned before, this is not the only choice. It also supports using SQL Server as an attribute store, and developers are also free to create attributes, custom attribute stores as well. So you can basically query anything you want, an SAP system, an XML file, a SQL Server. You get an API that allows you to code that. Another point that I want to make here, though, is that claims-based identity doesn't necessarily require ADFS. So any SDS from any vendor, or even a custom-built SDS, that's, as long as it supports standard protocols and token formats, can be used. However, one of Microsoft's primary goals when providing ADFS was to make widely available a fully featured SDS built on Active Directory. The other thing we get with ADFS is we get a claims processing engine. So as I mentioned, in a federation role, ADFS can issue tokens whose claims differ from the claim set that it received. So to help do this more intelligently, ADFS includes a rules engine that allows you to define this transformation. All right, so let's talk about some related components to ADFS. So in the cloud, as I mentioned in the beginning, Microsoft provides the Windows Live ID as an identity provider SDS. Windows Azure App Fabric Access Control, or ACS, will actually provide a federation, a cloud-based federation provider. And then when we talk about custom code and building an identity library, then our applications can use Windows Identity Foundation. So, Windows Live ID basically implements an identity provider SDS in the cloud, and you're probably very familiar with it. The most popular applications that accept tokens issued by this SDS are all Microsoft offerings, like Hotmail, but any application can choose to accept these tokens. It is not usable only by Microsoft itself. So that's all great, it's useful to have an identity provider SDS in the cloud, but when you're on-premise, and when we talk about on-premise identity management, you probably don't want to let your employees log in with Windows Live ID or Facebook. You want a SDS that you can control. And this is where ADFS comes in. So how many people here know that ADFS is part of Active Directory? So it's basically free. It is available to you at no extra cost, so this makes claims-based identity immediately accessible to a large number of organizations. What if we have a scenario where we have an application running in the cloud and then we also have on-premise applications? Well, in that case, we're probably going to want to use the Windows Azure App Fabric access control in order to build a single sign-on experience for our users. So if we want to let our application that runs in the cloud to accept tokens that are issued by multiple on-premise identity provider SDSs, such as ADFS, then we are looking into implementing ACS. The other scenario where we would be considering ACS is if we want to accept identity that are issued by other cloud identity providers, such as Windows Live ID, Google, Facebook, Yahoo, or OpenID. So all this we cannot configure directly with ADFS. We have to go through ACS. And ACS, just like ADFS, also provides built-in support for claims transformation. And it also allows client requests using various protocols. And it can accept and issue tokens into a variety of formats. So now that's all great. We have all these tokens that are containing claims, but they're kind of useless unless our applications are able to accept and use them, right? So, so this is where Windows Identity Foundation helps us. Windows Identity Foundation is basically a set of .NET Framework classes that implement essential identity functions, such as receiving a token, verifying the signature, accessing the claim set that the token contains. And with the Windows Identity Foundation, we can support tokens that are created by using SAML 1.1 or SAML 2.0 formats, or we can accept tokens issued by ADFS, by ACS, or any other SDSs coming from different vendors. So each claim is extracted into an instance of a Windows Identity Foundation defined claim class, and that provides developers a consistent way to work with the tokens information. So you can access things like the claim type, the claim value, the issuer, regardless of whether and how that claim was produced. So one thing to mention here is that Microsoft itself is using Windows Identity Foundation to add support for claims-based identity to its own products, including SharePoint 2010. And with Windows Identity Foundation, the other thing you can do is you can actually create a custom SDS. So even though there's the primary goal of ADFS is to reduce the need for you to create your own custom SDS, there may be instances or scenarios where custom SDS makes sense. So keep in mind that ADFS itself is built with Windows Identity Foundation. All right, so let's look at a high-level architecture of an ADFS solution. So as I mentioned before, we could link to another ADFS server, say our partner organization, ADFS server. And ADFS could be a relying party as well as an identity provider. We can configure other identity providers to work with ADFS. We can register, for instance, as I mentioned before, ACS, or Windows Azure App Fabric Access Control, which in turn can support Facebook or Google. We can also write our own identity provider and configure it to work with ADFS. We can query SQL, Oracle, or an XML file, or whatever we want. So basically, this just shows you how much flexibility we have in terms of integrating with a number of IDPs out there. One thing to remember is that SharePoint only supports SAML 1.1. So when someone says to you that they have an IDP that only supports, say, SAML 2.0, then we have to tell them to put ADFS in the middle. So SharePoint to ADFS, ADFS to their IDP, and then things are going to work. All right, so this is an example of an enterprise deployment architecture for ADFS. So we could have load balance proxy ADFS servers say residing in your DMZ, calling the ADFS servers on the corporate network, which in turn will access the Active Directory. So ADFS can use SQL Server in the backend, or it can use the Windows internal database and this is required for its configuration database. So in this diagram, we show SQL Server just because, obviously SQL Server is a better choice if you can, because it gives you scale, it gives you high availability, it gives you backup mechanisms. And you can implement high availability as shown here. All right, so with this, let's just see how we get to configure ADFS to talk to SharePoint. So, this is just an overview of the major steps. ADFS needs a number of certificates. It uses a certificate to sign the tokens that it sends out. And this ensures to the consumer of the token that the token has not been tampered with since it has been created. So when we configure SharePoint, we'll need a copy of that certificate. We also need a certificate for the ADFS endpoint, and you'll also have to make sure that you have a certificate for your web application. So all the communication happens over HTTPS, so you need to have your web application configured for that. We also need a ADFS service account, nothing special there, it's just a regular domain account. We need to install the ADFS service. We need to run the ADFS Federation Server Configuration Wizard, configure ADFS to use the token signing certificate, and configure the relying party. All right, so with this, I'm just going to switch to my image here. All right, so what I have here is basically an ADFS server. Okay. So let's just walk at high level at the steps required to configure ADFS to have knowledge of SharePoint and the claims that we want to pass to SharePoint. And we want to use a claim set made of two claims, email and role. So I'm logged into a domain controllers that doubles as an ADFS server. And what I've done here is I've actually enabled already ADFS, and you do this through add roles and features. It's very straightforward. You turn on the ADFS feature. And you also have to make sure that you have the necessary certificates. So what I've done is I've already generated my certificate for the ADFS endpoint. And I'm just going to show you. So I've decided to use a self-signed SSL certificate. So I've enabled the certificate authority on my ADFS server. So that's why you can see here Active Directory certificate services enabled. And this is, again, the same process. You go through roles and features, and you just enable it. So if I go to my IIS server, I'll show you I've already installed a certificate on my server. Okay, so there it is. I gave it a friendly name of ADFS server, so I know which one it is. The one thing I want to point out here is that you have to always make sure that if your certificate is not the highest in the chain, then you have to make sure you grab the root certificate as well when you configure the SharePoint site to have knowledge. The SharePoint site to have knowledge of ADFS. So so this is my certificate. And I've also already created an ADFS user account. So that's simply an Active Directory user with no special permissions. So I already have all this done. And the next thing I have to do is I have to go through my ADFS management console and configure SharePoint as a relying party. So if you remember, relying party means that SharePoint can consume the claims that are issued by ADFS. So in here, I have a link that says add a trusted relying party. So this is where I'm going to start. And I'm just going to assume that I have a SharePoint web application that is called, say, teams.contoso.com. So this is the web application that I want ADFS to have knowledge of. So I'm going to click on, I'm going to start going through the wizard. So I'm going to go in the first screen. So on here, we have to select enter data about the relying party manually. So if you remember what I was mentioning about a metadata endpoint, we don't have that. So we have to manually enter the information about the SharePoint site ourselves. All right. So the display name is basically just a user-friendly name that will help you identify which relying party you configured for which web application in your ADFS. So I'm going to call this, because my SharePoint site is named Teams, I'm going to give it a friendly name of SharePoint Teams. All right. And in here, we're going to leave the default for the ADFS profile that we need to select. We're not going to encrypt our certificate. So keep in mind that all our communications is anyway over HTTPS. And in here, what we have to do is we have to enable support for WS Federation Passive Protocol. So if you remember, when we look at the diagram with all the signing processes that happen, a lot of it is HTTP gets and posts. So this is why we need the WS Federation Passive Protocol enabled, because this is what supports the web browser based communication. So in here, I have to enter the relying party protocol URL. And what I'm going to put in here is going to be HTTPS teams_trust. So basically what this means is ADFS is asking, where do I redirect the users after I authenticate them? So this is the URL that is basically our SharePoint STS endpoint. All right, and in here we have to enter a relying party identifier. And the format that is used for this is this one. And you can have, I've decided to use the name of my web application and to also identify this as coming from SharePoint. But you can enter any sort of values that you want in here, as long as you make note of them, because you're going to need the exact same rail when you configure the SharePoint site. All right. I want to permit all users to access this relying party. And I am done. So, so basically all I've done so far is I've told ADFS which web application is going to accept these claims. But I haven't configured any claims per se. So this is the next step. And I have the edit claims rules dialog box checked, so this is going to open now. All right, and here is where we actually configure the claims. So I'm going to click on Add Rule, and I want to point out in here that all the different options that we have, we can configure LDAP attributes, and this is what we're going to do in this demo. But we can also transfer an incoming claim, we can pass through or filter an incoming claim, and very important, we can send claims using a custom rule. So this is basically your entry point into adding any other extra claims that you want. This is how you would be able to query, say, a SQL store or a custom attribute store. Once you register that store with ADFS, then you're able to use the send claims using a custom rule option to configure exactly the extraction of the value that you want from your attribute store. So in our case, we're going to use LDAP attributes as claims. And we need to give it a name. Again, it's a friendly name. So because my site is called Teams, I'm going to say Teams rule here. And here's where we have a number of Active Directory attributes that are exposed out of the box through ADFS. So what I'm going to select is email addresses, and we have to map this to an outgoing claim type. So I'm going to map this to email address, and then I want to map, this field contains group memberships, and I want to map this to an outgoing claim called role. So again, you're not limited to the options that you see here. You can have additional Active Directory attributes that you can configure to pass on as outgoing claims. Oh, and I haven't selected my attribute store, which is Active Directory. All right, so here is my, my claim rule for the team site. I'm going to say apply and OK. All right, so, so from a configuration standpoint, there's nothing else we have to do in ADFS. This is all. There's only one thing that I would like to do, and that is if I look under certificates, okay, so as I mentioned, ADFS generates itself some certificates, and now it may be that they're not really what you want. It may be that you want to have some certificates that are you know, self-signed or trusted, generated through your trusted authority. So in that case, you would go through here and you would actually add a token signing certificate that you generated or purchased with, you know, an expiration date and everything, and you would just add it in here, and you'd set it to be the primary token signing certificate. So, so that's pretty much all that needs to happen on the ADFS side. So I'm going to just flip back to the slides. All right. So, so what happens next? So next we have to do the configuration on the SharePoint side. And there's, again, a number of steps that we have to take. So first of all, we need to get a copy of the ADFS token signing certificate. So what I showed you in my, as installed on my ADFS server, we have to obtain a copy of that as well as a copy of any parent certificate in the chain. And after that, we get to open PowerShell and start configuring the SharePoint Trusted Provider, the SharePoint Trusted Root Authority object. So the first thing we do here is these first two commands are going to add the token signing certificate from ADFS and the parent certificate to SharePoint. After that, we want to create the claim mappings that SharePoint is going to use. So everything that we configured, if you remember, 2 claims on the ADFS side, the email and the role. So SharePoint doesn't have knowledge of them. So we must map those claims to this object, to the SharePoint Trusted Root Authority, in order for SharePoint to understand those claims. So in here, we're also saying that the email address is the identity claim. So what that means is that when you type in the name of the site collection owner, you need to use the email address for that user, because we're saying that the email address is how we're going to identify a user. After that, we have to enter a variable for the realm that SharePoint will use. And if you remember, we enter that on the ADFS side. So it needs to match exactly what we enter there. And this is because this is how ADFS understands what rules, what claim rules apply to the relying party that is calling, that is communicating with. And finally, after we define all this, we get to create our SharePoint Trusted Identity Token Issuer object. And in here, we're basically tying everything together. We're passing in the name attribute. So the name attribute is what's going to show up when you configure your web application and you get a list of providers that are available to you. That is the name that is going to show up in there. So again, the realm, it needs to match exactly what you typed in when you configured ADFS. The import trust certificate is where we put in the certificates that we copied from the ADFS server. The sign-in URL is the URL that the users will be redirected in order to authenticate with ADFS, and typically that is the ADFS ls subdirectory. And finally, we have the identifier claim, which, as I mentioned, is the email address. All right, so after we do that, we just have to create a new web application. We have to, as I mentioned, make sure that it's HTTPS enabled, that we have port 443 selected, we have a host header that matches our certificate, and we can select claims-based authentication as the authentication type and the ADFS provider that we configured. And we're done. So that's pretty much everything we have to do on the SharePoint side. All right, so I just keep in mind that you can have a single token signing certificate, a single identity claim, a single sign-in URL. So again, the sign-in URL is the parameter that specifies the URL where the users are redirected in order to authenticate to the ADFS. But you can have multiple realms, and you can have multiple claim mappings. So multiple realms come in handy because you may want to have more than one web application that you enable claims-based authentication on. So, so in that case, you would need to have, you would use multiple realms. All right, so let's talk about some trade-offs and limitations of claims-based authentication. So when you switch from, if you convert an application from classic to claims-based authentication, then you cannot convert it back to classic. So just keep that in mind. As I mentioned, claims-based authentication requires communication over HTTPS with a token provider and an issuer provider. So as you've seen from the diagram with all the processes, there's a lot of redirects for clients that are using a web browser. So this is likely to be a little bit slower than Windows authentication or ASP.NET Forms-based authentication. For the search crawl, you're going to need to create a separate zone that supports Windows authentication for crawling. And finally, and I mentioned this, when you configure a web application to use SAML-based authentication, then the built-in SharePoint Claims provider does not provide search functionality to the people picker control. So because any text you enter will resolve, you will have to create a custom claims provider to implement custom search and name resolution. All right, so these are SharePoint features that will not work when you switch to claims-based. When you switch to a claims-based web application that uses, again, FBA or SAML security tokens, not Windows claims. Windows claims will all work. But if you want to switch to FBA or SAML-based authentication, then these features will not work because, unfortunately, they require a Windows security token. All right. Another thing to consider when you switch to claims is the impact on a number of services. So most of the time, you'll be able to get away with the secure store service and unattended data refresh accounts. However, for some features, you will simply there'll simply be nothing at all that you can do, such as, for instance, for Power Pivot, which only supports classic Windows authentication. So, so you have to take that into account when you design your solution. All right, so I just want to cover the SharePoint 2013 authentication changes. So with SharePoint 2013, we continue to offer support for both claims and classic authentication modes. However, claims authentication is the default authentication option now. So that means either Windows claims, FBA claims, or SAML claims. So classic authentication mode is still there, but it can only be managed in PowerShell. It's gone from the UI. So the only way you can create a web application that uses classic authentication is through PowerShell. And because of the deprecating support for classic authentication, which will go away in a future release, we strongly recommend that you move to claims authentication. So I want to talk a little bit about the process to migrate accounts from Windows Classic to Windows Claims. So in SharePoint 2010, we had a method called migrate users of the web application that we used to migrate users from Classic to Claim. So in SharePoint 2013, this has changed, and we have a new PowerShell commandlet that is called convert SharePoint web application that we're using instead. So here's a simple example on how to convert an existing Windows Classic web app. You just run the commandlet and you pass it to the web app to convert. You set the 2 parameters to claims and then use the retain permissions flag. So when you're planning to move from SharePoint 2010 to 2013, we strongly encourage you to do the claims migration first while you're still in SharePoint 2010, and then upgrade your farm afterwards. And this is easier because it will allow you to identify if you encounter any issues, whether they're generated by the content migration or by the authentication migration. So, yes?
But you just said that if we go one direction, we can't go back. So if something doesn't work, then forget it.
So that's what I'm gonna talk about next. How you do that? So to not end up in that situation, there's a number of ways you can go about it. So you can one way is you can create a SharePoint 2013 web application that uses Windows Classic authentication, which you do through PowerShell. You attach your SharePoint 2010 content databases to that. You upgrade the content, you test it and make sure that the content migration is fine, have no problem. And then you run this command, the convert SharePoint web application to convert your users from Classic to Claim. So that would be ideal. The other way you can go about it is we also have a different method that you can use to migrate just an individual content database. So the Convert SP web application allows you to migrate an entire web app. But what you can do is you can create a SharePoint 2013 Windows Claims authentication web application, and then you just attach your content database from SharePoint 2010 to that, so you perform your content migration, and then you run this method called migrate users to claim that will, on the database, that will actually migrate your users. So you have a number of options here, and hopefully it's going to go all smooth. All right. Other changes that happen with SharePoint 2013. Oh, sorry. Yes.
So let's say you use a guinea pig database. Things go disastrously wrong. If you delete that database and if you were using guinea pig content, then are you back to where you started?
So, well, I would say that I would recommend using 2 different environments. So you have your production environment with your real web applications and content databases, and then you have a test, say, SharePoint 2013 environment where you.
In a sandbox, so you didn't booger your dev environment, right?
Sorry.
You need to use a sandbox.
Yes.
So you booger your dev environment.
Yes, or I mean, if you'll configure anyways a SharePoint 2013 farm for your production, right? That will be your final production. So you actually have an opportunity to play in there. So as you know, there's no in-place upgrade, so you'll need to have a separate instance of SharePoint 2013 anyways. So in there, you can create your SharePoint 2013, say, dummy web application based on classic authentication, and then just transfer your content database to that and upgrade the content, migrate the users, see that if everything works, and if it doesn't, then you can just simply delete the web application and start over, right? So that would be probably the safest way to go. All right. So another change, a big change in SharePoint 2013 is related to the FedOps cookie. So just for those who don't know what that is, so when you log into SharePoint using FBA or SAML claims-based authentication, there's a persistent cookie that is written to disk to store the claims information. And this is basically to prevent you from having to authenticate again every time you close the browser and open it. So one of the big changes for SharePoint 2013 authentication infrastructure is that now we're able to use the distributed cache service. So SharePoint uses this caching service to keep track of this FedOps cookies for users who authenticate with FBA or SAML-based authentication. So how did it work in SharePoint 2010? Well, in SharePoint 2010, basically each web front-end server had to keep their own local cache and FedOps cookies. So as a result, every time you implemented load balancing, you had to worry about sticky sessions. So basically, you were required to use sticky sessions with your load balancer to ensure that once a user has been authenticated, he or she will be redirected back to the same server so that the authentication cookie can be found. So with the new distributed cache service, you can actually, to keep track of this authentication cookies, we no longer require sticky cookies when you use FBA or SAML claims. How many people are familiar with the distributed cache service? All right, so for those of you who are not, I'm just going to quickly say that basically what it is it provides an in-memory caching service, and it doesn't have any dependency on databases for a number of features in SharePoint Server. So some of these features are news feeds, security trimming, page load performance, and one of them is also authentication. So it helps with quick data retrieval, basically. Another change is that when you install a custom claims provider, there's a property there that used to be set to true by default. Now it's set to false. So when you install a custom claims provider, it's not going to just work automatically from the beginning. You just have to remember to turn that property to false. The property is used by default. And sorry, you have to remember to set it to true. So by default, it's set to false, and you have to enable it. SharePoint, with 2013, SharePoint will actually publish a metadata endpoint that describes its configuration and certificate. However, the format that it uses is JSON instead of standard XML, so it's not really, it's not exactly useful. So if you remember when we configured ADFS and we went through the relying party wizard, we selected on the first screen input information manually about the other parts. So that is the reason why, because we cannot communicate with the metadata endpoint that SharePoint STS provides right now. Finally, the last improvement is that there is more logging that is provided with, to help troubleshoot authentication issues. So you can configure ADFS logging. You can configure SharePoint for a maximum amount of user authentication logging and access that through the ULS viewer. You can use HTTP Watch or Fiddler as some really good web debug tools. All right, so I don't know if you had the opportunity to attend the sessions. If not, you can find them on the TechEd content website. Yes.
Once you've done your federation, what's the experience of the people sector in terms of seeing the people on the other side that you want to enable?
In terms of seeing the people on the other side.
You want to see those people with some of those people in your people picture so you can assign partitions.
Right, so you'll have to do, so there's a really good walkthrough on MSDN. If you do a search for claims walkthrough, custom claims provider, it's done by Steve Peshka, and it actually walks you through step by step how to accomplish that. No problem. So I strongly recommend my colleague's blog, Steve Peshka, which has a lot of good information and a lot of very practical hands-on examples and sample code, as well as, of course, TechNet and MSDN. Oh, sorry. No, this is if you use Windows, if you use FBA or SAML claims, it's not Kerberos. No. No. Yes.
Did I see your one slide say correctly that if you're using SQL 2008 R2 with SQL reporting services in integrated mode, that would not work with claims?
Yes.
Okay, so if you're using.
Sorry.
If you're using that right now with Kerberos, so that all has to be reconfigured with SQL 2012?
Yes. And there is, if you come see me after and give me your information, there is actually an article on that I can point you to.
Okay. Thank you.
No problem. So you guys know all about the evaluation. So please come up and let me know if there's any other questions. I'm going to be here for a while. Thank you. Thank you.